Let's get going then. So I gave you a challenge. The challenge was posted onto the YouTube channel where basically you had to create a pattern that you could scale in size with a polygon at all of the center points that that really would react to the rule set that I gave you in this panel. So create a grid, put a polygon on the points of the grid, and then make sure that it will not overlap the polygons next to it. So a lot of you got it correct and completed it just fine. Some of you had difficulty with that second rule, right? Where it has to not overlap the geometry next to it. The challenge is really that you need to think about things as a non-static element, okay? So those of you who might not have finished it, probably at first you looked at it like it was just a static object. Okay, it's not overlapping, so I'm fine. But then when I asked you to scale your grid down, then your geometry was still the same size, and so it overlapped, right? So these are the kinds of things that we're going to have to be thinking about readily as we work through Grasshopper pretty much at all times. All right, so I'm going to show you the solution here. And so I started off with a square grid. Excuse me, which is found under vector and grid. And so I gave you guys a hint about halfway through where I said a good thing to do in many cases is if you know what item you need to create, you can put that in the workspace and then work backwards from that point to help figure out what it is that you need for that element. So this was a polygon-based exercise. So if I go up to the Curve tab, and under the primitive menu, you'll see polygon. Or if you have trouble finding that particular tool, I know a number of you asked me, where is that tool? Where's the tool? You can double click and you can search for the term that you're trying to find. So if I typed in polygon, you'll see a couple of different types of polygon-based tools. And then it's really just a process of figuring out which one you want. So that part gets a little bit crazy. But it is this one right here, the polygon. That's under curve and primitive. So typically when I'm working backwards, what I do is I drop the command in and I start reading what does it need in order to generate these polygons. It needs a polygon base plane, and remember I said base plane is almost always interchangeable with base point. It needs a numerical radius, and it needs a numerical size, number of segments. And so that just determines whether or not you're doing a triangle or a square or a pentagon or a hexagon or whatever it is. And we didn't worry about the fillet radius the other day, or yesterday, and we're not going to worry about that today. So we can start to build the square grid and then kind of plug this all in and make it all well and good. So let's start doing that. The square grid really just needs a couple of sliders. We're going to need to give it the size of the cell and then how many cells there are. So I'll do a slider from 0 to 10. So double click in the space to do your shortcut, and then 0 less than 10 and hit enter. You can copy and paste that to make 3 of them, and then just start plugging them in. It'll give you the error when it's at 0, but after you pull it up to create your grids, go here, then you'll actually have a populated grid. Any questions on that so far? Nothing special. I think I saw that all of you had completed that just fine. So the next part is establishing the geometry on the grid. Okay, so I mentioned under the rule set that I wanted these polygons to be placed on the points of the grid. So if you read your grid output, you have cells, which a number of you I noticed were trying to find the centroid of the cell, which wasn't exactly what I was asking for. So if you just look down a little bit further, the points of the square grid is really the easiest path forward for that solution. So then you take the points and you can plug it into the base plane of the polygon, and you'll see that it'll populate it across your entire grid. And so generally, this is where you guys, some of you got hung up, right? Because you're trying to figure out, right here it looks like it overlaps, but if I push it up this way, it doesn't. And if I push it out one more, it is definitely not overlapping, and so I'm good. But really, the key is to be able to make sure that it is always not overlapping. So it's always separate from the one before. And so I mentioned to you that we can create relationships between these different types of geometry using old information. Old meaning it happens further to the left down the string of what we've done. So which bit of information might I be able to use to create a relationship off of the size of the polygon versus the size of the rectangle cell? The size of the cell, right? So if I create a relationship between the between the size of the cell and the size of the polygon, I pretty much just restated the answer, right? So the key really is to make sure that that radius has a mathematical relationship to the size of the cell. So if the size of the cell is 7, then the size of the radius of the polygon can be no more than 3.5. Or I can just state it to be exactly 3.5. And so I'll do that by going to Math and Operators, and I'll use division. And I'll drop in a static number from the panel to make it a divide by 2. So go under params and input and pull in a panel, double click it and make a number 2, and remember, don't hit enter. I'll explain that in more detail when it becomes relevant. But put in a number 2, and then you can plug in the size there, and so you'll see that you're going to get 3.5 on the output. So wrapping up this whole thing right here, there are only 2 more things I have to do to make it perfect. Obviously, I have to connect the numerical output to the numerical input of radius. And then at that point, the geometry is parametric. So if I go up and down, it will change size, and all is well and good. But I do have this other feature for Polygon where I can change the number of sides that it has. And so I'm going to change the number of segments to be anywhere from 3 to 8. So I'll say 3 is less than 8. And why did I choose 3?
Triangle.
Right, because it's a triangle. It's the smallest number of segments a polygon can have. So I'll plug that in here. You see the triangles. I can change it to a diamond. That's what you saw in the beginning, right? So the square pattern.
Is it less than 3?
3 is less than 8, going up to an octagon. So then this is the octagon, the one that makes that little star pattern. And they're all fully parametric. So how did that feel? Going through the exercise of generating it on your own. This is only day 2. I only gave you a couple of tutorials and then I released you to do something. So how'd it feel? Anybody? Anybody?
Feel what?
What's that?
Feel what?
How did it feel going through it? Was it surprisingly more difficult than you thought? Was it exceptionally easy? How do you feel about it?
More practice.
You need more practice?
Yeah, I thought the division part.
Mm-hmm. Yeah. So that's kind of the key, is that understanding that you can build those relationships into it at almost any point is really how you unlock the real power of Grasshopper. You know, because it's not just about putting a geometry on the grid and then telling it manually what size it's going to be. That is smart, but it's not the smartest thing you can do. The smartest thing you can do is build in another layer of relationship that'll basically give the number for you. Then you don't have to worry about it. You know what I mean? That kind of thing. So, but that doesn't apply in every case. It's just this one because those are the parameters that I set for you. All right. So I'm going to stop this video here, and then we're going to move into understanding more about dynamic patterning and two-dimensional list manipulation if there are no more questions. Okay.